This question came from Jason, who asked how long a nuclear submarine could survive in orbit. The answer was not very long, but not for the reason I expected. Submarines can withstand pressures from 50 to 80 atmospheres, so they easily maintain 1 atmosphere of air pressure inside. The hull will likely be sufficiently airtight, although waterproof seals do not always hold air. The fact that water cannot penetrate the hull under 50 atmospheres suggests that air will not escape quickly when the submarine is in space. The dangerous accumulation of carbon dioxide will not be a problem, as submarines use devices to remove carbon dioxide that can work indefinitely as long as there is energy. However, the situation with oxygen is different. Nuclear submarines use electricity to extract oxygen from water, but in space, there is no water, so they cannot produce new air. They have enough oxygen supplies to survive for a few days, but eventually, they will find themselves in a difficult situation. The real serious problem is overheating. Space is significantly warmer than the ocean. To be precise, it's not quite so. Space is actually very cold, but if you delve into the details, it's true in 2 aspects. Space in Earth's orbit seems cold due to its emptiness. Without a warm environment radiating heat, you lose warmth to radiation faster than usual. However, space in orbit around Earth is actually warm. Temperature is a measure of the average kinetic energy of a collection of particles, and in space close to Earth, molecules can have an average kinetic energy in the thousands of degrees. This does not make space feel warm to the touch. In my childhood, I watched my father use a metal grinding machine. When the metal touched the grinding wheel, sparks flew everywhere, sometimes landing on his hands and clothes. I didn't understand why they didn't burn him, as the sparks were very hot. Later, I learned that it was due to their size. The warmth they carried could be absorbed by the body without heating more than a small area of skin. Hot molecules in space resemble sparks in my father's workshop. They can be hot or cold, but they are so few and so small that they barely change the temperature. Instead, your heating and cooling depend on how much heat you produce and how quickly it escapes into the void. This is a practical reason why space seems warm. Without air or water around to carry heat away from your surface, you lose it only through radiation, which is not always efficient. For most spacecraft designed for humans, the main problem is not staying warm, but preventing overheating. A nuclear submarine not only transports people, it also contains a nuclear reactor with a power of 200 megawatts. It is difficult to obtain accurate data on the efficiency of nuclear reactors on military submarines, but according to conservative estimates of civilian reactors, about half of the reactor's energy, roughly 100 megawatts, is lost as heat. Usually, this heat is dissipated in seawater, but there is no water in space. Without cooling, a 200-megawatt nuclear reactor emits enough heat to raise the temperature of the entire submarine by about half a degree Celsius every minute. Within an hour, the submarine will become too hot for a human. However, the reactor is not designed to heat the submarine, so heat will accumulate inside the reactor, leading to its melting. It seems that keeping a nuclear submarine in orbit is not the best idea. To exit the orbit, the submarine needs to reduce its speed to enter the atmosphere, which will slow its movement. Technically, the submarine has rockets, but they are not attached to it. Launching missiles won't help the submarine, but they can simply be turned upside down. If the ballistic missiles on board the nuclear submarine are placed in the tubes backward, each one can increase the speed of the large submarine by about 4 meters per second. To maneuver out of orbit requires a speed change of about 7 kilometers per second, meaning that 24 Trident missiles on an Ohio-class submarine could be just enough to pull it out of orbit. However, since the submarine lacks heat-dissipating tiles and is not aerodynamically stable at hypersonic speeds, it will inevitably tumble and disintegrate in the atmosphere, with debris scattering through the air or crashing into the ground at several hundred knots. If you are strapped into a seat for acceleration in the right place of a submarine and you experience a sudden deceleration in the atmosphere, there is a tiny chance that you might survive. Then you will need to jump from the wreckage with a parachute before it hits the ground. If you ever try this, I have one absolutely necessary piece of advice. Don't forget to disable the detonators on the rockets.